Okay, so once it started down the plane, so it could sit on the plane, right? We figured that out in part B, right? It could sit on the plane, but once it started down the plane, we run into this notion that the parallel force right here, right, the 25.9925 is bigger than the friction force, right? So as it slides down the plane, we've got the parallel force acting down the plane, right? And that's 25.9925. And if you want to know where that comes from, look at the part A for this series, right? It's mg sine theta, right? And if it's sliding down the plane, then our friction force of 14.1429 will be up the plane, right? Because it's sliding down the plane. So this is going to be 14.1429. Right? There these guys are, right? So those would be the only forces because there's no outside force, right? So we're going to set this thing up. This will be positive, down this way will be negative. So parallel force is negative. The friction force is positive. Because it's sliding down the plane, friction will be up the plane, right? So now we just set up F equals ma. And we go negative 25.9925 plus 14.1429 equals 5.00 times a. We ought to be able to solve that, right? Okay, so let's see. Okay, so let's set this thing up. So, so what I'm going to do is I'm just going to go this guy plus this guy and then divide by 5, right? Okay, so let's see that guy. All right, so there we go. Okay, so now we're going to go negative a plus. And I get negative, when I do this, I get negative 11.850, roughly, right? It's 5. And now I can just divide by 5, right? And I get negative 2.3699 meters per second squared. And we could later ask, all sorts of SUVAT questions about, how far up and down the plane it would slide, right? I'm going to store that storage, and I'll store that in E. There we go. Okay, so there it is, right? So basically, because it was sliding down the plane, we need to know which way it's sliding down the plane, right? Okay, then friction will be up the plane. Parallel force is always down the plane, right? That's our force parallel. It's always down. Right? This is friction. That's our force of friction, our kinetic force of friction. And in this case, it's up the plane, right? Because we're sliding down. Right? And then we solve for the acceleration. Good enough?